Welcome back. In this video, I'm going to introduce the concepts of ratio and proportion. And these are concepts you have probably already seen in your math career, but it's always good to look at them again. So a ratio is simply a quotient of two numbers. Quotient meaning division. So oftentimes we see ratio written as a fraction. The fraction 5/3, 5/3, is an example of a ratio. So any fraction is a ratio. We can also write it as a colon, the ratio of 5 to 3, or you'll just see it in words as 5 to 3. And you'll also see it as like 5x and 3x. So the ratio of 5 to 3, we could write that as 5x and 3x, and we've seen that already this year in some of our classwork problems. Some samples of ratio. Ratios are all over the place, many places in our world. Real life examples. In algebra, we see it as slope, or any kind of rate of change is an example of a ratio. Miles per hour, miles per gallon, free throw percentages, pay, dollars per hour. When we saw slope, we were seeing a ratio. The ratio of students to teachers. A lot of schools or colleges will brag about their student-to-teacher ratio. So they want the lower students to teachers. Some talk about that. And something that's probably near and dear to your heart, the ratio of boys to girls at a school or on a team or that kind of thing. That's something you might look at. So just a couple examples there of ratios. Now a proportion is simply an equation, so a proportion has an equal sign, stating two or more ratios are equal. So here we have 1 out of 2 is the same as 5 out of 10. So that is an example of a proportion. And we might see written as a colon, 1 is to 2 as 5 is to 10. Or you might just have letters, A is to B as C is to D. In a proportion, so we had our proportion 1 is to 2 as 5 is to 10. Well, we could look at 4 different positions here, and we call the extremes would be in the first and fourth position. So this would be the first position, the second position, the third position, or the fourth position. Okay? So the extremes are in the first and fourth positions. So we look at that and we'd say 1 and 10 are the extremes. And if you look at that, those would be the high and the low. The highest number is 10 and the lowest number is 1. Those are the extremes. The other two numbers are generally the means. Now, they're not always in these positions, but in general, they're going to be in the second and third position. Okay? So these are going to be the means and the extremes. So that's something we'll talk about, and we'll use this in our vocabulary in class, because what we have with a proportion, as you probably know, we can cross multiply a proportion, or essentially we can multiply the means and the extremes. We can multiply the first and fourth position and the second and third positions in any proportion. So what we would say when we multiply out a proportion, we'd say the product of the means is equal to the product of the extremes. And in geometry, we have a theorem for that, and that's called the means and extremes product theorem. It allows us to multiply out or cross multiply a proportion. So if we have 1 is to 2 as 5 is to 10, then we know that 1 times 10 will equal 5 times 2. We multiplied our means and extremes. So if we had A is to B as C is to D, we know that A times D equals B times C. We can multiply out our proportion using the means and extremes product theorem. And the reason in the proof would be the means and extremes product theorem. In geometry, we also have the means and extremes ratio theorem. It's essentially the converse of the means and extremes product theorem. It allows you to undo the multiplication back into a proportion. So we had A is to B is C is to D, so we had A times D equals B times C. So now we can go backwards and say, know that A and D would be our extremes, and B and C would be our means. Interestingly enough, though, as long as we can multiply back, this is going to be the same as A is to C as B is to D. This is going to be the same proportion, because when we multiply it out, we get the same thing. So the means and extremes ratio theorem also says we can set up a proportion differently and still get the same result. So A is to C is B is to D, we can read across, or we can go up and down. A is to B is C is to D. A is to C is B is to D. So as long as it multiplies out the same, it is fine. So earlier we did 1 is to 2 as 5 is to 10. Well, that's no different than 2 is to 1 as 10 is to 5, because when we multiply the means and extremes, we get the same thing. Or we could say 1 is to 2 as 5 is to 10. When we multiply out, we get 1 times 10 equals 5 times 2. That's the means and extremes ratio theorem. We can set up our proportions differently and still get the same result. Continuing with our studies here of ratio and proportion, another thing that we're going to see here is the arithmetic mean, which is simply the average. So if we're going to find the arithmetic mean of something, that just means we are finding the average. Okay? So if we wanted to find the average of our math scores for our class, I'd add up all the scores for the entire class and divide it by the number of students who took the test. So you add up what you have and you divide by the number in the sample. So we add everything up. Here we have 6 scores. We add those scores together and we divide by 6, and that is our arithmetic mean, or our average. The geometric mean, you'll see questions about the geometric mean. That's a little bit different. The geometric mean is also known as the mean proportional. And we'll have, if we wanted to find the mean proportional between 3 and 27, we would set up our proportion with 3 and 27 being the means, and our x's, our unknown, would be the extremes. In fact, I said that backwards. If we wanted to find the mean proportional between 3 and 27, 3 and 27 would be the extremes, and our x, or our unknown, would be the means. That's what we're looking for. So we can cross multiply or multiply the means and extremes. So 3 times 27 equals x times x, or x squared. So x squared equals 81. And then we want to solve for x, so we can take the square root of both sides, and the square root of x squared is x, and the square root of 81 is 9. But since we're taking the square root of both sides, we always do plus or minus. So x could be positive 9 or negative 9. So be careful when square rooting both sides. Make sure you do the plus or minus. So, and there's an example of finding the geometric mean or the mean proportional. So a little bit more vocabulary for you to make sure you have that in your notes as well.